question relates to the relationship between distance, speed, and acceleration. So it tells us that the speed of a raindrop continues to increase until it gets to its maximum speed, and then it keeps going at that speed. This is called terminal velocity. It's something from physics that you don't need to know for this question. You just need to know that the speed gets bigger and then it stays the same after a certain point. The distance, s for distance, it falls is given by these two functions. So up until 10 seconds, this tells you the distance. After that, this tells you the distance. The reason it changed is because up until 10 seconds, the speed was increasing all the time, so it was a more complicated function. After that, it's the same velocity. It's constant velocity, so k for constant. But it turns out you don't actually need to use this function, this one here, at all during this. This is just to cover their tracks to show that it's terminal velocity after 10 seconds. So part A, how far has this raindrop fallen after 10 seconds? So how far, that's distance, so that's s, after 10 seconds, so that's t. This is our function for s, plug in the value of t, replace every t with 10 and raise it to all the powers, you'll get 80 meters, don't forget the units. Part B, after how many seconds, so this is t question mark, our question mark here is t, what we're looking for, t question mark, is the raindrop falling at a speed of 8.25 meters per second. Like that. So they're saying that the speed here is equal. Now we don't have speed, but we can get it. The way you go, when you have distance, speed, and acceleration, the way you go from one to the other is differentiation in this direction and integration in the other. So that means if you have distance, differentiate it to get speed, also known as velocity, and differentiate it again to get acceleration. To go backwards, integrate, and integrate again. If you have velocity, integrate to go back to distance, or differentiate to go to acceleration. So that's how it works. And it's always with respect to time. So instead of dx here, it's dt for time. Although it doesn't matter what letter you use, just as long as you know it's time. So differentiate this to get the speed. So differentiate 6t, you're left with just the coefficient 6, because if you're minusing the power here, it goes to t to the power of 0, which is 1. Multiply by 2 minus the power. Multiply by 3 minus the power. Set that equal to 8.25 and get the value of t. So it's a quadratic, so you'll get two values of t. You can factorize it or use the minus b formula. If you're going to factorize, it makes sense to simplify it, to get rid of those decimal points, so to multiply everything by 100, and then to divide it all by 3. But you could equally use the minus b formula as long as you've transferred everything over to one side. So you've got two values of t, which makes sense. Now in this particular question, only one of them is valid. They didn't ask us for two values. And the reason only one is valid is because we have 5 or 15. But this function is only valid up to 10 seconds. That's the one we used. So this gets crossed out. This is our answer. T equals 5 seconds. Okay, so part C here, the acceleration, so think acceleration you want to differentiate again of the raindrop is increasing for the first 10 seconds, which makes sense, or the acceleration of the raindrop is decreasing, excuse me. Find the value of t for which the acceleration is 0.006. So it's very similar to this part. Differentiate to get the acceleration, set it equal to 0.006. To move this over by subtracting it, and then divide by -0.06, and you'll get t is equal to 9.9 seconds.